solving any problems on polynomials, especially finding g of x, r of x, q of x, you should remember two important points. Now let us consider this polynomial x cube minus 2x plus 5. Now as you can see, this is a cubic polynomial, right? And let us consider another equation, x square plus 5x cube plus 6 minus x. So let's consider these two equations, these two polynomials. What you have to remember is that first bring the polynomial in standard form without changing the value of the original polynomial, and secondly rearrange the polynomial's variables in descending order of its exponent. Descending order of its exponent. For example, first you have to check these two before you start solving polynomials. Now if you see this, x cube, x raised to 1 and 5. Here x raised to 2 is missing. But for the convenience of solving, let us just take it as 0x square, then bring, because in place of x square we write 0x square, 2x raised to 1 plus 5. This will make your simplification easier without much confusion. And then second point that you need to remember is arrange them in the descending order of the exponent of the variable. Now the highest is this, so first put this as the first term, and x raised to 2 is the second term, and x raised to 1 is the third term, and you should take it along with the sign minus x plus 6, right? Now we have the exponents in descending order. So before solving any polynomial related problems, you have to follow these two thumb rules. One is adjust the polynomial to the standard form and arrange the exponent in descending order. Yes, let us begin solving exercise 2.3. We have been given p of x and g of x in this, and we are supposed to find q of x and r of x in each of these cases. So without explaining again, I will write using the two thumb rules. First one. Now p of x should always be written like this here, minus 3x square plus 5x minus 3, and g of x is written here. Now g of x, what they are given here is x square minus 2. So x raised to 2 is there, but x raised to 1 is not there. So let us arrange it in the standard form, x square plus 0x minus 2. Yes, so we have it in the standard form which reduces errors. Yes, now let us take the first term of p of x to get the first term of q of x. We need to get the first term of q of x. So this is to get first term of q of x. So this is p of x, this is g of x, and this is q of x. And what we get in the end is r of x. So to get this, first let us take this term x cube divided by x square. The first term of g of x is constantly used in the denominator, x square. So using law of exponent, it goes up, it becomes x. So let us take the first term is x. Right? Now we will start writing this line. Now we have to multiply every term of g of x by x. So let's begin. X times x square, x cube. Plus into plus, plus. X times 0x, 0. Plus into minus, minus. X times 2, 2x. Change the sign. You don't have to do anything with this actually. Plus. Cancel. What are you left? Just take whatever is there in this. Just ignore this part. We have minus 3x here. Minus 3x square. Then plus 5 plus 2. Now this minus has changed to plus now of this here. So you consider it as plus 2 and not minus 2. That's what is called changing of sign. This is plus 2. So plus 5 plus 2 plus 7x minus 3. Okay. Now we need the second term. Second term. Second term here. The first term of this polynomial is our second term. Along with the sign minus 3x square. As I told you before, the denominator will not change. X square. Cancel. So you have minus 3. So it is minus 3. So what do we have now? Minus into plus, minus. 3 times x square, 3x square. 3 times 0, 0. Minus into minus, plus. 3 times 2, 6. Right? Sign change. Here, no need to do anything. This plus will become minus. Minus 3x square plus 3x square cancel. We have plus 7x. Minus 3 minus 6 is minus 9. Now the question is, when do we stop this? Yes, we stop at this stage because the degree of g of x is greater than degree of r of x. So when do we stop? We stop when degree of r of x is less than degree of g of x. Here this is x raised to 1, right? So degree of this r of x is 1 because highest is 1 and degree of g of x is 2. So this is lesser than this. Yes, so this tells us we have to stop. So this is your r of x. Right? So what is you are supposed to write? Now q of x is equal to x minus 3 and r of x is equal to 7x minus 9. This is clear? So observe one more thing here, children. Degree of p of x is x cube, degree of g of x is x square and degree of q of x and r of x is 1. This is first problem. Now let us solve second problem. Let's follow the thumb rule. Here equation given is x raised to 4 minus 3x square plus 4x plus 5. The degree of this polynomial is 4 and x raised to 3. The term with x raised to 3 is not there. So let us take x raised to 3 plus 0 x raised to 3. Then the remaining equation will come as it is. Take care to check the sign when you are writing the polynomial. And to write g of x. Now the g of x given here is x square plus 1 minus x. As I told you, the second rule of thumb is that you have to check the order of the exponent. Here you see x raised to 2 is there and x raised to 1 is here. So our order should be x raised to 1. Along with the sign you take minus x and shift this plus 1 here. Now we have it in the standard form. And let us take this as our g of x. X square minus 6 plus 1. Now let us try to get the first term of q of x. So whatever you get here is your q of x. So to get the first term of q of x, let's begin with the first term of p of x. So first term, x raised to 4 and divide by the first term of g of x, and remember this will remain constant for all the terms. X raised to 2, which is equal to x raised to 4 minus 2, x raised to 2. So this is our first term, x raised to 2. Now let us multiply every term of g of x by this first term. X raised to 2 into x raised to 2, x raised to 4. Plus into minus, minus. X square times x, x cube. Plus into plus, plus. X square times 1, x square. So now we have, this is minus, this is plus, and this is minus. Plus x raised to 4 minus x raised to 4 get cancelled. Here, ignore this part. Just take this as minus x cube plus x cube. So this is minus 3 minus x square is minus 4x square. Bring this down. So this will be, now let us try to get the next term. Second term is x raised to 3 divided by, this will remain the same, x square. So this will be x raised to 3 minus 2. This 2 is nothing but this 2 shifted here, x. So it is plus x. Now let us start multiplying. Plus into plus, plus. X into x square, x cube. Plus into minus, minus. X into x, x square. Plus into plus, plus. X times 1, x. Now change the sign here. Plus 6 cube minus 6 cube get cancelled. Now minus 4x square plus 1x square is minus 3x square. Then plus 4 minus 1 is plus 3x. Now our first term of this is 3x square. So now degree of this and degree of this is still same. So let's continue our division. Third term of q of x. This is minus 3x square divided by x square. As I told you, denominator will not change. X square. So it is minus 3. Now let us take minus 3 here. So now let us multiply every term of g of x by minus 3. Minus into plus, minus. 3 times x square, 3x square. Let's bring this down. Okay. Minus into minus, plus. 3 times x, 3x. Minus into plus, minus. This is 3. What happens? This will change, sign change. This will be plus. So what happened here? Minus 3x square plus 3x square. Plus 3x minus 3x. plus 5 plus 3 is plus 8. This is our R of x. This is R of x and this is Q of x. If you observe, your P of x is, the degree of your P of x is 4. Degree of G of x is 2. Degree of Q of x is 2. And degree of R of x is 8. This is the second problem. Now let's move on to the third problem. Here the P of x given is x raised to 4 minus 5x plus 6. You see, this is x raised to 4, this is x raised to 1. So 3 and 2 both are missing. So let us rewrite our P of x as x raised to 4 plus 0x cube plus 0x square minus 5x plus 6. Yes. So now our P of x is ready. Now let us see what is our G of x. Now G of x given here is, in the problem they have given it as 2 minus x square. So we can't take it. We have to apply both the rules here. What is it? First one is to get it in the standard form. Or one rule is, first you arrange it as, it is, let me write again, 2 minus x square. So first put this minus x square here. Minus x square. And we don't have x raised to 1. So 0x raised to 1. Plus, this is plus 2, right? Plus 2. Once again I will repeat. See, we tried to arrange it, right? So we wanted, this is our constant which should come in the end. Minus x square. So we took it along with the sign. And this is plus 2. Since there is no x raised to 1 given, we wrote it as 0x raised to 1. So now our equation is ready for simplification to find Q of x and R of x. So now let us find the first term. Let us take x raised to 4 and divide it by minus x square. So put the minus here, no problem. Minus x square. So here minus x raised to 4 minus 2, which is minus x square. So along with the sign, take it here, minus x square. Next. Now let us multiply every term of g of x by this. Minus into minus plus x square, x raised to 4. Minus into, okay, this is just minus. X square, this will become 0, right? So, then minus into plus, minus. X square times 2, 2x square. Yes. Now this is minus, this is plus, this is again plus. So minus x raised to 4 plus x raised to 4 minus x raised to 4 get cancelled. Here it is 0. This is 0. 0x cube. This is plus 2x square. Then bring down minus 5x. Now since this is 0, let us not take this term. Now let us take this to find the second term of our Q of x. This is 2x square. And let us divide it by minus. So put the minus here and say x square. This will become minus 2. This is minus 2. So this will be minus into minus plus 2 times x square, 2x square. Plus into minus, minus. This is 0. This is plus 4. Now bring this also together, right? So what do we have now? Minus, plus, minus. Plus 2x square minus 2x square. This is minus 5x. We have to ignore the 0 part. Plus 6 minus 4 is plus 2. Now, degree of r of x is less than degree of g of x. Because this is 1 and this is 2, we can stop at this. So, this is what our q of x. Q of x is minus x square minus 2 and r of x is minus 5x plus 2. And we have to use the same approach to solve all the problems of second way. The same approach is used. So as I told before, once again I will remind. Once again, see now in the second way, you have been given t raised to 2 minus 3 and the second polynomial given is 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12. This is the second polynomial, right? This is the first polynomial, this is the second polynomial. So here you are supposed to find whether this is a factor of this. This will be a factor of this only if r of x becomes 0. The remainder becomes 0. So for example, you have to follow the same method here. Just write your second polynomial. See, it could be t, x, y, whatever it is. The variable can be anything. Now here, what is the thumb rule now? There is t raised to 2. Where is t raised to 1? It is not there. So what are we supposed to do? Write it with 0. So I will rewrite it as t square plus 0t minus 3. And then do your division like how we did for the first way. And how do we conclude? Now if this is 0, then first one is a factor of second one. You should say yes, it is a factor. If the value is not equal to 0, then you should say no, it is not a factor. You should say no, it is not a. Now let us see how to solve this third problem. It is given obtain all the other zeros of 3x raised to 4, 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5. And they have given two zeros. First, when they say find all the zeros, first we should understand how many zeros at most this polynomial can have. Now since this is x raised to 4, degree of polynomial is 4, so we should get 4 zeros. We should get 4 zeros. And now let us see how many zeros they have given and how many zeros we have to find. Now they have given root of 5 by 3 and minus root of 5 by 3 plus root of 5 by 3 minus root of 5 by 3. They have given two zeros and we have to find how many more zeros now? 2 more zeros because degree of polynomial is 4, right? Now, how do we start this? These two are zeros means we can say x is equal to plus root 5 by 3 and x is equal to minus root 5 by 3. If you recall finding the zeros of a quadratic polynomial, you will remember finally we get x is equal to x is equal to, right? When the zeros are given, which means x is equal to plus root 5 by 3 minus root 5 by 3. Okay. Now I will just transpose this plus root 5 by 3 to left hand side. X minus plus will become minus root 5 by 3. Okay. And this is x plus root 5 by 3. Right. And now these two put together will be a factor. Right. Now this is nothing but, if you observe carefully, this is like a minus b, a plus b. Do you observe? A minus b, a plus b, which is a minus b times a plus b is nothing but a square minus b square. So we will put this here. Right? So we will say a square minus, what is our a here? X. So this is nothing but x square minus b means root 5 by 3. B square. Right? A square minus b square. Our a is x and b is root 5 by 3. This is a minus b, a plus b form. Okay. So now we have x square minus, now root 5 square of any root is just the real number. You get like this, 5 by 3 is equal to 0. Right? So now we will take, let's multiply every term by 3. So it becomes 3x square minus 5 is equal to 0. I'll just do this here. If you get confused, just say I am multiplying every term by 3 because I want it in the standard form. I do not want this 3 in the denominator. So I will say 3 times 5 by 3 equals 0. So what does it become? 3x square minus 5 is equal to 0. Right? Now arrange this in standard form. When we arrange this in standard form, we get 3x square plus 0x minus 5 equals 0. Yes. So what is this, children, now? This is our g of x and this is our p of x. Yes. So this is our g of x. Now let us take this g of x here. Just see this once again. This is p of x and we have been given that root 5 by 3 minus root 5 by 3 are the zeros and we took them like this, a minus b, a plus b, and we got this as our g of x. So what is our g of x now? I will write it here. 3x square plus 0x minus 5. Now let us try to find the other zeros. So how many more zeros we need to find? We need to find 2 more zeros because degree of polynomial is 4. 2 zeros they have given and 2 zeros we have to find. So use the usual method, okay, of finding q of x. First let us find what our q of x will be. Okay, so now take this to find the first term. It is 3x raised to 4 divided by first term of g of x will be denominator. 3x square cancel, x raised to 4 minus 2 which is x square. So this is the first term. Multiply 3x raised to 4 plus into plus, this will become 0, plus into minus minus, 5 times x square is 5x square. This is minus, this will become plus. Cancel, this, ignore this part since it is 0. So take this as plus 6x cube. This is minus 2 plus 5 is plus 3x square. Bring this minus 10x down. Now take this. This is your second numerator for the second term numerator. This is. Every time this first number of the first line will be the numerator of this term. So just write exactly here, then you will remember. Take it as 6x cube divided by, this will remain constant. See, 3x square, 2. So it is 2x cube minus 2, 2x. So what 2x? Plus 2x. Okay. So now let's multiply quickly. This is 6x cube plus 0 plus into minus, minus 10x minus, no need to worry about this is 0, this is plus. So this will be plus 6x cube minus 6x cube, and we are left with 3x square. This is minus 10x plus 10x, right? Now this is still equal, right? And let us take this minus 5 down. So we'll continue because degree of r of x and degree of g of x is still the same. We need this lesser than g of x. So let us take this. This is our third term. See, exactly in the same line I am taking this. This is our numerator. Denominator will remain the same. Cancel. It becomes 1. What 1? Plus 1. Right? So this will be 1 times 3x square. 3x square. 0. Let's ignore. Plus into minus. Minus 5. So this will become plus. So this will become minus. And this will become plus. Cancel. 0. Yes. Now, the next important step is, we are still not finished. We have to find 2 zeros. We still haven't found 2 zeros. Now, let us take this now. X square plus 2x plus 1. Okay. Let's consider x square plus 2x plus 1. Now, this is a quadratic polynomial. We do splitting the middle term. X square plus x plus 6 plus 1 equals 0. Grouping x, x plus 1 plus 1, x plus 1 equals 0. So we have x plus 1 as the factors. So x is equal to minus 1, x is equal to minus 1. So we found the 2 other zeros, minus 1 and minus 1. Finally, what are the 4 zeros of this polynomial? What they have given? Plus root 5 by 3 minus root 5 by 3 minus 1 minus 1. Right? Degree of polynomial is 4. So we got minus 1 and minus 1. Both these are our zeros. Now let us solve fifth main of 2.3. Here we are supposed to create such polynomials, that is p of x, g of x, q of x and r of x, which satisfy the given condition. The first condition is, we must find all these 4 polynomials satisfying the condition degree of p of x should be equal to degree of q of x. Degree of q of x. So it's very easy to understand. I'll tell you. Take a very simple polynomial, just one term polynomial will also do. You try to recall the terms that we got when we were doing long division of polynomial. first term, second term, third term, like that. So just take a single term polynomial. That is, for example, if our polynomial p of x is 3x cube. Now when will you get q of x also to be 3x cube? When you divide this by 1, right? So we can say, we can give like this now, or if you want to take, let us say 6x cube. Let us say our polynomial is 6x cube, and let our g of x be 3. G of x be 3. So what happens now? 6x cube divided by 3 will give us 2x cube. So in the long division method, if you want to understand, this is 2x cube, which is our quotient. In long division, I will show you 6x cube divided by 3. Right? 2x cube will give us 6x cube. 0. So now what is this? We get 2x cube, or this is our q of x. This is our p of x, and we have both the degrees same. So our examples of this condition polynomial can be p of x is 6x cube, g of x is 3, then q of x is 2x cube, r of x is 0. Like this, we can create polynomials for the other conditions also. I will just show you for the other conditions. Use a single term polynomial, no problem. Degree of q of x is equal to degree of r of x. So when do we get degree of q of x and degree of r of x? Same. Now let us say, for example, you have a single term polynomial 6. You are dividing it by 3, right? Or you just take polynomial 6 only. Let's take this polynomial 6. Now 3 2s are 6, 0, right? Now here r of x, degree of r of x is 0, degree of q of x is also 0. You can take anything like this, okay? Then the third condition is degree of r of x is equal to 0. You can use the same example for degree of r of x is also 0. The same example what we use for the second one, we can use for the third one also. With this, we complete exercise 2.3 of polynomials.